Now that we have the lines down pat, we're going to jump into linear inequalities. So remember, anytime we have an inequality, it's going to be some interval or a region. So it's not necessarily a single point. So basically, we're going to be looking for where in our coordinate plane do we satisfy the given inequality. So we're just going to talk about what does a linear inequality actually look like, and then we're going to jump into graphing and just do a bunch of examples. So really the only difference that happens between the equations and the inequalities is that equal sign is replaced by an inequality symbol. So we're dealing with our standard lines in two variables, and it could be that, one of these is 0, so we could be dealing with horizontal or vertical lines or something that has a slope. The only stipulation we want is that both of those aren't 0, so I don't end up with like an inequality 0 is less than 3, because that would be relatively boring. So just to give you an example as to what one looks like, and we'll go through and jump into how do we actually solve each of these. If I have a line that we know how to plot using that intercept and our slope, let's go up 3 and go 3 in each direction to make life easy. So if I pick a line that has a y-intercept of +1, and then its slope is also +1, so we go up 1 over 1, up 1 over 1. Another point would be here. I can go ahead and connect the dots on these, and here is our line. And this line would be y equals, our slope is 1 and our y-intercept is 1, so it is y equals x plus 1. On 1/2, maybe I'm going to be shading this region here. So let's go ahead and shade that in. This would be all y values that are bigger than the line. So this inequality would be y is greater than the line x plus 1. And then everything on this side is we pick y values that are smaller than the line. So the inequality would be y equals x plus 1. This would be the region that satisfies it. This cutoff point between the two is called our boundary line. Okay. So when we're given an inequality, there's really just 3 steps that we're going to take. So the very first thing we want to do is we're going to ignore the inequality sign, and we're going to replace whatever it is, whether it's a less than, a greater than, less than or equal to, or greater than or equal to. Immediately switch it over to an equal sign and graph that line. If it's going to be the less than or equal to or greater than or equal to, it means points on the line will satisfy the inequality. So you're going to graph that as a solid line. If, however, you have one of the strict inequalities, so there's no bars underneath, it means your points on the line are not going to satisfy it. So we're going to use a dotted line or a dashed line, whichever method you prefer. So this indicates that the line itself is important, but I can't actually equal anything on it. Once we've done that, then we're going to choose a test point, something that does not fall on the line. And you're going to plug it into the inequality. And you're basically looking for, do I get a true statement using this point? So from there, you're going to shade one side. And so we're shading the appropriate region. If the test point you picked worked, you're going to shade that side because the test point is good. So everything else on the same side as the test point works. If the test point does not work, however, it means the opposite side is going to be the solution to the inequality. Okay? And so we'll go through and we'll pick test points that don't fall on the line or that don't work, just so we can get a feel for it. So I really just have examples that we're going to go through. And this is, again, tying all the information we know together, because we've got to graph lines. We've got to see if something works for the inequality. So the one we're going to start with is we want to graph 4x minus y is less than or equal to 4. So the very first thing we're going to do is we're going to graph the line. And because we have the bar underneath, we're going to graph a solid line. And that line is 4x minus y equals 4. This, however, is not nice to graph, so I'm going to put it in slope and intercept form. So we subtract our 4x, and that gives us negative y is equal to negative 4x plus 4. And then I'm going to go ahead and divide everything by negative 1, which really just changes all of my signs. So I want to graph the line y equals 4x minus 4. My slope is positive 4. My y-intercept is negative 4. So we're going to do that over here. So I need to definitely go out 4 in every direction. I'm going to go out 5. So each of my marks is going to be worth 1. So we start by graphing our y-intercept, which is at negative 4. And then my slope is positive 4, so I go up 4 and then over 1. And this is my other point on the line. Okay. And now, because I can graph it as a solid line, I just go ahead and connect my dots. Okay. So this is our line y equals 4x minus 4. So now that I've got my boundary, I'm either going to shade this side over here to mean all of these points satisfy my inequality, or I'm going to shade this side. So our second step is we need to choose a test point. And the one I'm going to pick is 0, 0. I want something that is not on the line. So I'm going to label that TP as test point. So we plug that back up here and see if it works. So we're dealing with the inequality 4x minus y is less than or equal to 4. If I plug in x is 0 and y is 0, we want to see, do we get a true statement? 4 times 0 is 0, minus 0. We end up with 0 is less than or equal to 4. So this point works. So the third and final step is, since this point works, we shade this side. So every other point over here would satisfy the inequality. Okay? So if you picked a different test point on this side, you would still find out that it's going to work. Okay? So let me show you what happens. Maybe if I picked this point, 5, 0, as a test point, and I plug that into the inequality. If we plugged in x is 5 and y is 0, we would end up with 20 minus 0 is less than or equal to 4, which is 20 is less than or equal to 4. So this test point wouldn't work, which means you shade the other side. Okay? So it really makes no difference what point you pick. 0, 0 is just always nice. And then for completeness, I'll show you, just in case you don't believe me yet. If we picked a different test point, say up here of 0, 5, that is not on the line. If I plug that into the inequality, that would be 4 times 0 minus 5 needs to be less than or equal to 4, which is 0 minus 5 is less than or equal to 4, and you get -5 is less than or equal to 4. So picking a different point still gave us a right solution to the inequality. So this entire region is going to satisfy the inequality. Okay. So that is all we're doing in this section. You graph the line, pick a point. If the point works, you shade it. If it doesn't, you shade the opposite. So let's try a second one. We've got x plus y is greater than 0. And here, because we do not have that equal to bar underneath, it's going to be a dotted line. So we're going to graph the dotted line x plus y equals 0, which we've got to rewrite in slope-intercept form. So we subtract the x, and the line is y equals -x. So our slope is -1, and our y-intercept is nothing, because it's like we have -x plus 0. So we need to graph this line. We'll just go out 3 in every direction. And I need to graph it as a dotted line, so, or dashed. Our y-intercept is 0, and our slope is -1. So we go down 1 over 1, and another point on our line is here. You can keep going down 1 over 1, down 1 over 1 to get more points. But then we're going to connect this with a dotted line. So this is our graph of y equals -x. Now we got to pick a test point. And I'm going to pick here at 3, 0. And so if we plug that into our inequality, which is x plus y is greater than 0, we'd have 3 plus y is greater than 0, and we end up with 3 is greater than 0. So this point happens to work, so that means everything on this side also works. So we shade exactly the same side. And for good measure, I'll go ahead and pick this point to show that it doesn't work. If we plug in -1, 1, we would need x plus y to be greater than 0, which is -1, -1. Be -1 plus -1 is greater than 0, which gives us -2 is greater than 0. So that point does not work, which means that entire region does not work. So our very last example is going to actually be a combination of two inequalities. We want this first inequality to hold, and we want the second inequality to hold. So really, there's one region that's going to work for both of these. So what we want to do is we want to graph the first inequality. 3x minus y is greater than or equal to 3. We'll do that right here. Then we also want to graph the second inequality. Y is less than 3. And then finally, we're going to combine to a single graph. And we're going to see where that shading overlaps. So let's start with the first line. 3x minus y equals 3. And we want it to be solid because we have that bar underneath. So we've got to put it in slope-intercept form. So let's go ahead and subtract 3x, which gives us -y equals -3x plus 3. And then we need to change the sign on everything. So it gives us y is equal to positive 3x minus 3. Okay. So we graph this, we need to go out at least 3 in every direction. And so our y-intercept is down at -3, and our slope is +3 over 1. So we're going to do a rise of 3 and over 1 to give us another point on the graph here. And then I get to connect the dots as a solid line. So this is y equals 3x minus 3. Now we pick our test point, and I'm going to choose right here at 0, 0. So if we plug that in, it would be 3 times 0 minus 0 is greater than or equal to 3. Or really 0 minus 0 is greater than or equal to 3, which is not a true statement. So this side did not work. So really the solution to this inequality on its own is right over here. Now I'm going to do exactly the same thing for the second line. And I don't have the bar underneath. So this means we're going to graph y equals 3 as a dashed line. Okay. And so that is going to be a nice horizontal line. So we got to go up 3. And we'll just keep consistent, do pretty much exactly the same thing as our last graph. Okay. So that is a horizontal line all the way up here at 3. And I'm going to pick exactly the same test point. Might as well. We'll pick 0, 0. Go back and label this one. If we plug that in, we get 0 is less than 3. And that does indeed work. So that means everything on this side works. And now what we do is we combine these to a single graph, and there's only going to be one region that works for both of these inequalities. So I do get to cheat a little bit because of my iPad. This is our first inequality. Here is our second. So if I lay them right on top of each other, it's not going to be the prettiest because they weren't exactly the same. There is just this region here that works for both of my inequalities. So combining to a single graph, try to make this a little bit neater. So you can see it much better. We've got our dotted line up here of y equals 3. We've got our solid line here, which is y equals 3x minus 3. And the region that works for both of them was this bottom right region. So I've got to be below the dotted line to the right of the solid line. And so this is our overlap. What you can also do is instead you can pick a test point that falls into each of these different regions, and then you're looking for one that satisfies both. But I think it's a little bit simpler to graph each of them separately and then just combine and see the overlap of the two.